everybody. Quick video here on arithmetic sequences. We are going to look at how an expression can be written if we are given an arithmetic sequence. So if I'm looking at a sequence, which is simply just a list of numbers separated by commas, and it does fit an arithmetic sequence, can I create an equation to find certain terms in that sequence? So we'll look at that today. We'll look at how we can create explicit formulas, which is basically the equation that we're looking at in part 1 there. And then, are there any restrictions on sequences? So we're going to take a look at the domains and ranges of arithmetic sequences today. All right, starting off, we need to know what a sequence is. Obviously, I had mentioned it was a list of numbers that were separated by commas, but with an arithmetic sequence, there's a special pattern in your list of numbers. And that pattern is that you are adding or subtracting the exact same number each time to get to the next term in your sequence. And that number that you are adding or subtracting by each time is what we call the common difference. And you're going to see an equation on the next slide to how we get formulas for sequences. But there are some notations that you need to know, so make sure this gets down in your notebook. So you're going to see the term a sub 1 a lot, and that is referring to the first term in your sequence. N is referring to the number of terms in the sequence. So if we're looking for the 23rd term, N would be 23. A sub n is referring to the last term in the sequence. So if they give us a finite sequence, A sub n is going to be the last term. And D is what we call that common difference. So remember, that is what we are adding or subtracting by each time. All right, so get this down in your notes. This is what we call the explicit formula for an arithmetic sequence. And again, we're going to see this a little bit later on because there's another formula as well. But this is the formula that we use 95% of the time for finding certain terms in our sequence. So here is the explicit formula. It's going to be a sub n equals, so this is a certain term in your sequence. It's going to equal your first term in the sequence plus n minus 1. Remember, n is that term that you're looking for. So if it's the 23rd term, n is 23. And d is that common difference, the number that you're adding or subtracting by each time. So those descriptions that we had down here on the previous slide all align with what we see in our explicit formula. So if you need to pause the video, don't hesitate to pause it now. Make sure this gets down in your notebook. All right, let's look at some examples real quick. First of all, is the sequence arithmetic or not? So are you adding by the same number each time to get the next term or no? Let's take a look at the first one here. Again, if you want to pause it to try and guess yourself and then see if your answers are correct, you can do so. The first one is no, it is not, because you're adding 1, and then you're adding 2, you're adding 3, and then you're adding 4. So there is a pattern, but you're not adding the same number each time. So that is going to be a no. In the second sequence, it looks like we are subtracting 150, and then we're subtracting 150 again, and subtracting 150 again. So I would say that yes, this is arithmetic. In fact, our common difference is going to be a negative 150. And the next one, it looks like we're subtracting 2 and then adding 4, subtracting 2 and adding 4. So yes, even though there is a pattern, this is not arithmetic because we are not adding the same value each time. And the last one you can probably guess is yes, it is. We are adding 10 each time, so we would say the difference is 10. So that common difference is a positive 10. Okay. You can show your sequences in multiple ways. What we've seen so far are just lists, but don't forget that you can also express your sequence in a table. So n is just telling you the number of the term. So the first term is 3, second term is 6, the third term is 9, the fourth term is 12. So notice how that does compare here. Right, there's the actual sequence. And then you can plot the points too. But notice they have an important note here. Notice how these are not connected with a line because a sequence is simply discrete set of points. All right, it's not continuous in there. So you cannot connect your sequence with a line, even though it should look linear. Okay, so it should look linear. You do not want to connect those with a line. And I'll go back and say a little bit more on what the difference between discrete and continuous is. If I were to connect these with a line, that means that I can include the points in between these, right? And 4, or for the y value, isn't actually in my sequence at all, right? So that's why we want to keep them discrete, because the values in between these y points or y coordinates are not included in my sequence at all. So that's why we don't want to connect them with a line. Okay, so we've already seen the explicit formula. There is something else called the recursive formula. We don't use this one too often, but what we have here is a sub n equals a sub n minus 1 plus d. The subscript n and n minus 1 refer to the place of the sequence a term is. So the first term is obviously a sub 1, the second term is a sub 2, and so on. And the word recursive actually contains the prefix re, which means again. So it's a recursive process where each term must be known, and then the process is applied again and again. So you have to know the number before it in order to get the next term in the sequence. So the number before it plus your common difference will give you the next term in your sequence. We don't use the recursive formula that often. Like I had mentioned earlier, we generally stick to the explicit formula when we're finding and evaluating certain terms in our sequence. Okay, we can also write our sequence as a combination of functions, and we can only do that if one of the functions is a constant. Okay, so let's say your first function is a constant, and that would be your a sub 1. And your second function is d times n minus 1, so you have this linear expression here, right? If that's the case, you can go ahead and add these together to create a formula for your arithmetic sequence, and then you can go ahead and manipulate and use that formula. Domain and range, this seems a little bit complicated when you read through it, but it's really not that bad. What it's stating is that the domain of an arithmetic sequence is always going to be n is greater than or equal to 1. Okay? Because the domain is referring to the number of terms in your sequence. Okay? And you can't have a negative amount of terms in your sequence. In fact, you can't even have 0 terms in your sequence, right? So again, don't forget that the domain is referring to the number of terms that you can have. Okay, so that's why we want to say that n is greater than or equal to 1. The range can be anything. So the actual terms that you get in the sequence can be positive, they can be negative, they can be fractions, they can be 0. So really the range is the actual numbers in your sequence, and that doesn't have any restrictions. So the range, I guess we would say, is just all real numbers. All right, let's look at some examples here. It says, given the functions f of n equals 11 and g of n equals negative 2 times n minus 1, combine them to create an arithmetic sequence and solve for the 31st term. All right, so remember when we looked at combination of functions, one of them had to be a constant, and the other one had to be linear, which is what we have here. So all we need to do is add those together. So f of n, which is 11, plus your negative 2 times n minus 1. And we're going to say that that equals the arithmetic sequence there. Because I have a plus and a minus here, the minus does take over. So if we want to just delete that plus sign and kind of move our negative to the middle here, we can do that. Okay, so there's our sequence, not too bad at all. Now we just got to find the 31st term. So we're looking for a sub 31. So we're going to substitute 31 in for n and then solve. And we get a negative 49. So the 31st term in our sequence here is a negative 49. Okay, let's find the 10th term of our sequence. So now we need to create an explicit formula to help us find the 10th term. So we need to know what a sub 1 is. So that's your first term, so that is 3. We need to know the common difference, and that is what we're adding or subtracting each time. So here we're adding 2, so the common difference is 2. And we are looking for the 10th term, so n would be 10. So when I write my formula, remember that's a sub 1 plus n minus 1 times d. We will get a sub 1 is 3 plus 10 minus 1, which we know is 9, times d, which is 2. And we get 21. So the 10th term in our sequence is 21. What about the 25th term? Again, let's list out what we know. So a sub 1 is negative 7. We know the 25th term, or n is 25, that's what we're looking for. And d, I am adding 3 each time because our numbers are getting larger. So it is a positive 3. Okay. So a sub 25, so the 25th term will be negative 7 plus n minus 1 times d. So let's simplify here. We should get 65. So the 25th term in this sequence is 65. Okay. Let's identify the 23rd term of an arithmetic sequence, or a sub 1 is 3 and a sub 7 is 6. So this means the first term is 3 and the 7th term is 6. So in order to do this, we actually have to create 2 equations because we need to figure out what d is. Okay? We know a sub 1 is 3. We know that n is 23, but we don't know what d is. So we have a little bit of work to do. So let's create an equation using these facts here. So a sub n, so a sub 7 is 6 equals the first term, 3, plus n, well we said n was 7, times d, and we don't know what d is. So a sub n we said was 6, that's coming from right here. The 7th term is 6, and maybe I should write that out. So when I'm writing my formula, I get the 7th term is 6. So 6 equals the first term plus the 7 minus 1 times d. Okay, let's work backwards to solve for d. So we're going to subtract 3 from both sides, divide by 6, and we get d equals 1/2. Okay, so now we know what d is. We can go and we can figure out what the 23rd term is. So we're still going to use the first term plus n, which we know is now 23, and d, which is 1/2. So 22 times 1/2. 22 times 1/2 is 11. 11 plus 3 is 14. So the 23rd term is 14. Okay. I want you to go ahead and try this one now on your own and bring the answer to the live class. All right, so the question states, a display of cans on a grocery shelf consists of 4 cans on the top, followed by 6 cans in the next row, 8 cans in the third row, and so on. How many cans are in the 15th row of the display? All right, so you should have enough information. Don't forget to use that explicit formula and come to class with your answer. I will see everybody in the next live class. Thanks.